Okay, so now let's talk about adding and subtracting polynomials. So here's some vocabulary. Again, in my class, I will not give a vocabulary test, but I will use vocabulary that I expect you to know. So this might be a good time to hit pause and take some notes over these vocabulary words. So a monomial is a term of this form right here. And hang on, there we go. And A is a constant. So the number in front of it is a number, okay? It could be a positive or a negative whole number, fraction, decimal. And it says here that the exponent, which is m, is a positive whole number, okay? And so we also have other words. So a polynomial is a monomial or two or more monomials combined by addition or subtraction. This is key right here, the addition or subtraction part, okay? We also have very specific names. So I've already told you about a monomial. Binomial is exactly two terms, and that means separated by an addition or a subtraction sign. A trinomial has exactly three terms. Again, each monomial is separated by an addition or subtraction sign. And then anything beyond trinomial, we don't use the word quadnomial or anything like that. We just call them polynomials. And polynomials, poly, it means many. Here's some examples. Don't write this down, but these are some examples of polynomials. So again, a polynomial is just a generic term that could mean two terms, three terms, or many terms, okay? But look at monomials. Monomials have only one term. This right here, even though there's x and a y, they don't have a plus or a minus sign in between them, so that's considered one term. Okay, the binomial has two terms, notice, separated by a plus or a minus. Trinomial has three terms, separated by pluses and minuses. Okay, so at this point, maybe hit pause and to yourself think about whether these are monomials, binomials, trinomials, or just polynomials. Okay, so do it on your own and then see if you're right. Okay, so part A would be a trinomial. Part B would be a monomial. Part C, there's more than three, so we would call that just a polynomial. Part D, there are two terms here, so that's a binomial. And part E is a monomial. Oops, there we go. We're going to talk about the degree of a polynomial in this class, but this is really as far as it goes. Later on, the degree will mean something to how a graph looks, but we won't really be talking about that in this class, but you will be introduced to the word degree in this class. Okay, so the degree of a term is the sum of the exponents of its variables. The degree of a constant is 0. That's important. We'll talk about that more in here in just a second. Degree of a polynomial is the highest degree of all its terms. Now, let me show you what I mean by this. All right, so on this one, on part A, so we're going to find the degree. The degree is the highest exponent of all of its terms. Part A, the degree is 1 because there is a 1 up there in the exponent. You don't see it, we don't usually write it, but it is there and it's understood to be there. On part B, it's the highest degree of all of its terms. This one has an exponent of 3. This one has an exponent of 1. This one has an exponent of 0. Okay, so this one is our highest degree. That is our degree here, is 3. On C, this is a constant term, okay? So this has a degree of 0. On D, the highest exponent is a 2, so the degree is 2. And on E, this one's the tricky one, okay, because look at this. You've got 1 here and you've got 2 here. You have to add those together and you get 3. So the degree on E is 3. All right, so to add and subtract monomials, first of all, you have to have like terms. In order to have like terms, your variable or variables, I'm going to put the S in parentheses because it may or may not have multiple, and your exponents or exponent or exponents have to be the exact same. Okay? In order to add or subtract. Notice your variable is a y, there and there, and the exponents match. That means that we are allowed to either add or subtract the coefficients. So 25 plus 15 is 40, and then our variable and exponent do not change. So this is our final answer. All right, so on this problem, the first thing you should do is look at your variable. Yep, they match. Okay, we are subtracting a negative. Don't forget, when you have a double negative, we can actually make that a plus, right? So now we can add 16 and 7, and we get 23. Don't forget your variable, 23p. All right, on this problem, we need to look at our variables. So this and this are like terms, okay? So I'm going to underline those with the same number of underlines. This thing right here, there's nothing to add to it because there are no other d squareds in this problem. So this right here will just be written down at the end of our problem. So we've got a 1c squared minus a 6c squared. So what is 1c squared minus 6c squared? Negative 5c squared. And then I've got to just write this because it doesn't have anything to combine with. So this right here is our final answer. I know you're probably looking at this going, doesn't look very simplified to me, but it kind of is. We went from 3 terms to 2. So yeah, we did simplify it some. Sometimes that's the best you can do. All right, so now we're going to add some polynomials together. Notice there's a plus sign in between. And what I like to do is I like to underline my like terms with the same number of underlines. So this is like terms with this. So I'm putting 1 underline under its like term. This and this are like terms. And then this and this are like terms. Okay? So now let's do 5y squared plus 3y squared, which is 8y squared. Don't forget, this is a minus sign in front of this 3y, so really you can say negative 3y plus negative 4y, which is negative 7y. And then we've got positive 15 plus negative 11, which is positive 4. And this is as good as this gets. We cannot combine anything else. The reason why we can't combine these two is because their exponents are not the same. So this answer is as simplified as we can get it. Okay, I want you to be really, really careful with minus signs. In fact, what I really would like to see you do is change the minus to a plus here. Plus, and then you have to distribute the negative 1, okay? So whenever you change that sign to a plus, you want to change the sign of each term in the next set of parentheses, okay? So everything gets changed to its opposite. All right, so we have like terms there and there, there, and there, okay? So now 9w squared plus negative 2w squared is 7w squared. That got rid of that and that. This does not have anything to combine with, so I'm just rewriting it, and that goes away. Positive 5 plus positive 4 is 9. And remember, every term has to be separated by a plus or a minus. So I see students try to do this all the time. And it doesn't make any sense. Okay, so make sure that if it's a positive number, it has a plus in front of it. If it's a negative number, it has a minus sign in front of it. Okay, here's our trick problem right here. Whenever we see the words subtract this from this, it means you have to reverse the order of these things, okay? And this gets students every single time. So really what it's saying is do this. And now we want to distribute our -1 here, so change this to a plus, change this to a minus, change this to a plus, change this to a minus, okay? So now our like terms are here and here, here and here, and then here and here. So 7c squared plus -c squared is 6c squared. Gets rid of that. -5c plus 4c is -1c or -c. That goes away. Then I've got 3 plus -7, which is -4. And this is it. This is as good as this thing gets. All right, so now we've got multiple variables in here. And again, I always underline with the same number of underlines. My like terms are here and here, and then here and here. And this guy doesn't have any like terms, so it's just going to get written at the end. So u squared plus 3u squared is 4u squared. That goes away. -6uv plus 2uv is -4uv. And then this guy that just follows us along for the ride. And this is our final answer. All right, again, distribute this negative sign to each term immediately following. So change it to a plus, but change the sign of every term immediately following. Okay, and now like terms are here and here, and then here and here. Okay, so p squared plus -p squared, those cancel each other out, right? So they go away. This guy would be next, pq would be next. There's nothing to combine it with. That goes away. And then q squared plus 2q squared is 3q squared. And it's positive, so it's got a plus sign in front of it. All right, that's it for this problem. All right, so what if you have multiple polynomials that you're adding and subtracting? Remember whenever I said you only want to distribute the minus sign to the polynomial immediately following? So this would stop right there. A closed parenthesis sign is a stop sign. Do not distribute a negative past a closed parenthesis, okay? So we would have minus and minus right there. That gets changed to a plus. Now, our like terms, let's see here. A squared b, this would be this and this. AB squared would be that and that. And that's it. Those are the only like terms that we have here. Remember, it has to have the exact same variable or variables and the exact same exponent or exponents. Okay, so a to the third power, this guy, goes away. Okay, a squared minus a squared b plus a squared b, those guys cancel each other out. They're opposites of each other, so they go away. Then we have ab squared, right here, a negative ab squared and a positive ab squared. Well, those cancel each other out too. And then this doesn't have anything to combine with. So that's it. We're done with this problem. All right, so on this problem, we're going to evaluate the polynomial 3 different times for 3 different values. So when x equals 4, when x equals -2, and when x equals 0. Okay, so on part A, that means we're going to put 4 in everywhere we see x. Okay, so then I'm going to put 4 in where we see x. I don't know where that line came from. And then we've got -8 times 4. Now we're going to simplify this. 4 squared is 16. So I've got 5 times 16 minus, I can go ahead and do that math too. So 5 times 16 is 80 minus 32 plus 4. So 80 minus 32. So 48 plus 4, and we get 52 here. It's our final answer. All right, let's look at part B. So on part B, we're going to put in -2 this time. So I've got 5 and then -2 squared minus 8 times -2 plus 4. So -2 squared is +4. 4 times 5 is 20. And -8 times -2 is a +16. 20 plus 16 is 36. And 36 plus 4 is 40. All right, last one. So now we're going to put 0 in. This one's the easy one. So the 0 squared, 0 times 0 is 0. 0 times 5 is 0. -8 times 0 is 0, so all of these are 0, plus 4 is 0. All right, so the polynomial -16t squared plus 250 gives the height of a ball t seconds after it's dropped from a 250-foot tall building. Find the height after t equals 2 seconds. So I'm going to put 2 in where I see t. Okay, 2 squared is 4. -16 times 4 is -64. And when we add these together, we get 186. What though? What does this mean? 186 what? It says it gives the height of a ball after it's dropped from a 250-foot tall building. So 186 feet after 2 seconds. So think about the ball is dropped from 250 feet after 2 seconds. It is then at 186 feet. All right, last problem. So it says the polynomial 6x squared plus 15xy gives the cost in dollars of producing a rectangular container whose top and bottom are squares with the sides of x feet and the height of y feet. Find the cost of producing a box with x equals 4 and y equals 6. So we're just going to put in 4 for x. Oops, I can't write. And 6 for y. Okay, this is the kind of thing where like I tend to grab my calculator so that I don't make silly mistakes. And I get 360 right there. And I get 456. 456 what though? What does it mean in the terms of this problem? And it says the cost. So it is the cost in dollars. So $456 is the cost to produce the box of these dimensions. All right, that's it for this homework. And if you have any questions, don't hesitate to reach out.